Okie dokie, this is section 11.5, areas of similar figures, starting on page 821. Number 1, for each pair of similar figures, find the area of the green figure. So, we need our scale factor here. So the scale of the blue to the green is 8 to 4. We'll call that our A to B factor. And go ahead and simplify that, and you get 2 to 1. So these two shapes are in a 2 to 1 ratio. Therefore, their areas will be in an A squared to B squared ratio. So 2 squared to 1 squared is equal to 4 to 1. Now I can use this ratio, not this one, but this one, to solve for the missing area. So blue to green area. Blue area is 36. Find green area. Cross multiply. 4 times x is equal to 1 times 36. And divide by 4, and x is equal to 9. Nine square yards. Number 3, for each pair of similar figures, use the given areas to find the scale factor from the blue to the green figure, then find x. So in order to do this, we need to find our A to B ratio. So to find your A to B ratio, you have to take your area ratio, simplify it, and find the square root of that. So start off by taking your area ratio, and then start simplifying this. So I can divide them both by 5, and I get 175 over 63, and I can see that I can divide both of those by 7, so I get 25 over 9. So this is my A squared to B squared ratio. This is my ratio of areas, but we want to find the scale factor. So to find the scale factor, you have to find your A to B ratio. So to find your A to B ratio, you have to take the square root of your A squared to B squared ratio. So that would be equal to square root of 25 and square root of 9. So the scale factor of the blue to the green is 5 to 3. Then we want to find x. So to find this length, we use the scale factor, blue to green, blue to green. So notice that I put those in the same corresponding order. Then you cross multiply, so we take 3 times x and 5 times 21. And then we divide both sides by 3. And x is 35 centimeters. Number 5. Zola has a picture frame that holds all of her school pictures. Each small opening is similar to the large opening in the center. If the center opening has an area of 33 square inches, what is the area of each small opening? So to find areas, first we have to find the ratio of areas. So to do that, we're going to find our scale factor and square it. So our A to B ratio, we have corresponding lengths here of 1.2 and 3. So ratio of areas will be in an A squared to B squared ratio. So 1.2 squared would give us 1.44, and 3 squared gives us 9. So now that we have the ratio of areas, then we can set up a proportion and solve for our missing area. So if the area of the small to the large is a 1.44 to 9 ratio, and it tells us that the center opening has an area of 33 square inches, we want to put that in the correct spot, so that corresponds to the larger number. So the area here is 33 square inches. We want to find this area. So we cross multiply. 9 times x, and 1.44 times 33 And then we divide both sides by 9. And there's our area of the small picture. Number 7, for each pair of similar figures, find the area of the green figure. So we need our a squared to b squared ratio. We know our a to b ratio of blue to green is 7.5 to 15, or 7.5 goes into 15 two times, so I can simplify this. This is a 1 to 2 ratio. So therefore our a squared to b squared ratio would be 1 squared is 1, 2 squared is 4. So if the two figures are in a scale of 1 to 2, then their areas will be in a ratio of 1 to 4. So we'll use that ratio to set up our proportion. So 1 is to 4 as 60 is to x, and cross multiply. So x times 1 is equal to 4 times 60, which is 240 square feet. Number 9, find the area of the green figure. So once again, let's start off with our scale factor, 35 to 28. And simplify it. Always simplify it if you can. So if we divide them both by 7, we get 5 to 4. So my a to b ratio, my scale factor is 5 to 4. Therefore my ratio of areas will be a squared to b squared, or 5 squared, which is 25, to 4 squared, which is 16. Use this ratio to set up your proportion to solve for the missing area. So we have areas are in a 25 to 16 ratio, and the larger area is given, and we're looking for the smaller area. So here, if we cross multiply, we get 25x is equal to 16,800, and divide both sides by 25, and x is equal to 672. Don't forget your units, square centimeters. In the next section, for each pair of similar figures, use the given areas to find the scale factor of the blue to the green figure, then find x. So we know that our areas are 96 and 150, so we're going to try to simplify this first. Both are divisible by 3, and then once again divide them both by 2, and you get this. So this is my ratio of areas. I want to find the scale factor. So to get from a squared to a, I have to take the square root of this number. From b squared to b, I have to take the square root of this number. So my scale factor is 4 to 5. In other words, this is in a 4 to 5 ratio. So I'm going to use that ratio to solve for x. So 4 is to 5 as corresponding side 14 is to x. And you cross multiply, and you divide. So x is 17.5 inches. Okay, so we want to find the scale factor and x on number 13, so we'll set it up in the same way as the last problem. Our areas are 846, which corresponds to 376. We can divide both of those by 2, and we get 423 over 188, and then we can divide them both by 47, and we get 9 to 4. So this is my a squared to b squared ratio. Therefore, taking the square roots, we get 3 over 2. So my scale factor is 3 to 2. Use the scale factor to solve for x. So x represented by this 3 here. So 3 is to 2 as x is to the small one, 24. Cross multiply. 2x is equal to 3 times 24, which is 72. Divide both sides by 2 and you get 36. For number 15, Caitlin wants to use one of 2 regular hexagonal cake pans for a recipe she is making. The side length of the larger pan is 4.5 inches and the area of the base of the smaller pan is 41.6 square inches. What is the side length of the smaller pan? So the first thing that we need to do is find the area of the base of the larger pan. The larger pan has a base side of 4.5 inches. So you can see in my diagram here that it's a regular hexagon, which means that all of these sides are the same and all of these interior angles are the same, with a side length of 4.5. So anytime you have a regular hexagon can be split into 6 equilateral triangles. So if I want to find the area of my regular hexagon, the formula is 1/2 of the apothem times the perimeter. So the perimeter is really easy to find. That's just the distance around this shape. So the perimeter is equal to 6 sides, each of them 4.5. So 6 times 4.5 is 27. But we also have to figure out what our apothem is. So what is the apothem? The apothem is the distance from the center to the edge. So that perpendicular segment there. Since a regular hexagon can be split into equilateral triangles, then it's fairly easy to find the apothem for a regular hexagon, because if we split our equilateral triangle in half, we get a 30, 60, 90. So if I want to find this length right here, notice I blew that up for this diagram. So half of 60, this angle would be 30. This angle down here is 60, and then of course I have 90 here. Half of the side, since the entire side is 4.5, half of 4.5 is 2.25. And if that's my short side, then to find the long leg, I multiply that by the square root of 3. 2.25 times the square root of 3. And then that is my apothem. So my apothem is 2.25 times the square root of 3, and my perimeter is 27. Therefore, my area is approximately 52.61. And that would be square inches. So the area of the base of the larger pan is 52.61 square inches. The area of the smaller pan that was given to us, 41.6. So I can set up my ratio of areas as 41.6 over 52.61. If I want to find my scale factor, a to b, then I'm going to take the square root of each of those areas. And once again, this is just approximate values. So an approximation for the square root of the area is 6.45 over 7.25. Now that I have a scale factor, I can use that scale factor to find a side length of the smaller pan. So the scale factor is smaller pan to larger pan. So I want to find a side length of the smaller pan and I have a side length of